Alright guys, we'll see this time how to create application that is run by Podman together with systemd, and this application will actually run on demand. So we'll have it listening on a socket, and when the socket is started, we'll be able to create a container, and after some time, if the application is not being used, the container will be terminated. Here is the idea. So basically we make a request towards a proxy server, which will activate our socket. The proxy afterwards will forward the request towards our web server. I followed this guide here. Basically, we're creating an HTML file in www data directory. Afterwards, we are logging to the Red Hat registry and we are pulling the HTTPD. Out of it, we are creating a pod with the name of HTTPD, and we're exposing the pod to port 8080 while mapping the volume of what we have in this directory, so this hello world, into var_vv HTML inside of the container. And of course, we're using the downloaded image for the creation of the container and running the pod. Inside of this directory, all of our service configuration files will reside. And the next is to use Podman to generate a systemd config file or unit file using this HTTPD pod that we just created. Let's now go to the terminal to see this in action. Right, so we are inside of this config systemd user directory, and we have one file which is called container HTTPD proxy service. Inside we are requiring the container HTTPD service and the container HTTPD proxy socket. And what interesting is that this proxy service will run the proxy daemon and will redirect all the requests received on our proxy to localhost port 8080. Also, exit idle time is set to 30 seconds. So after 30 seconds, our container will be disposed if there is no activity. Let's now look at the other files. So container HTTPD proxy socket. And here we define that we will be listening on our local address on port 8080, and whenever we have a query to this address, we'll be redirecting by the proxy and we'll be starting our container serving the request. Then we have the actual service, container httpd.service. And as you can see in the unit section, we would like to start the configuration of the service after the internet is set up. And also this option is important to stop the service when it's not needed, so when we don't have request to it. Right, so the specifics you can find in the article. Basically, we are starting here the container in the exact start part of the service unit section. And now actually we can try to run a request towards our proxy. Let's see first with Podman PS that we have no running containers. And with nmap, we can see that also on our local host, we don't have running web servers. We can check also what's running inside of the proxy server address. And as we can see, we have 8080 port open to the proxy server. All right, let's execute a curl request to our service. We'll type curl and then the IP address of the proxy and port 8080. And we see in the first time empty reply for the server because the pod needs some time to start, but then afterwards we see hello world and it's still running. Now if we type Podman PS, we'll see that for 17 seconds we have started our pod and container. Actually, after the 30 second, this container automatically should be cleared up. And as you can see, now the container automatically stopped functioning. Again, if we run the curl we see again empty reply and then hello world. We'll see that we have started a different pod with different container inside, and it started on demand. And guys, that's of a great benefit for all services running on server, because this on-demand socket activation feature can save a lot of time by scaling up and scaling down services only when they are needed to the user. All right, you can experiment and by reading this article, you can achieve fully functional. By experimenting, you can implement this article and probably move some of your workload for more efficient resource handling. Thank you for watching, and please don't forget to subscribe to the channel.